Welcome to Creative World. In this video, we will solve Chapter 3 Learning Assessment E3.18. While solving this problem, we will be using Kirchoff's voltage law. According to this law, a cumulative supplied and dropped voltage across circuit elements in a closed loop is always equal to 0. We also will be using Ohm's law. According to this law, voltage across any resistance R is the product of current through it and the value of resistance itself. Now move towards the problem. Learning assessment E3.18. Find the value of voltage V0 in given below figure using mesh analysis. This is the circuit diagram of given problem. Inside this network, we have to find voltage across this 6 kilo ohm resistance labeled as V0. We know that in order to calculate voltage across any resistance R, we should have at least two parameters. One is the value of resistance and other one is current through that resistance. In this case, value of resistance is given but current through it is not provided. So first of all, we will try to find out current through this branch. Later on, we will be able to calculate voltage across this resistance. And in order to find current through this branch, we will apply mesh analysis technique on this network. As it is bounded in this scenario, we have to follow mesh analysis technique. In order to do mesh analysis of this network, first we have to assume currents along with their directions inside these closed meshes. So I am assuming current I1, current I2 and I3 are flowing inside these three closed meshes in clockwise directions. Now if we observe, current through this branch is provided in the form of constant current value of 2 milliampere. But this branch is in common with these two meshes, so there will be two currents flowing through this branch and both will be opposite in direction to each other. Now the direction of this constant current source 2 milliampere is in the direction of current I2, which may be considered as current I2 is larger than current I1. That's why their resultant current is flowing in the direction of current I2. So we may write this statement in mathematical form. Current I2 minus current I1 is equal to 2 milliampere. This 2 milliampere is the difference of these two currents that are flowing through this branch, and both are opposite in direction to each other. That's why one current is subtracted from other one. And because the direction of this constant current is in the direction of current I2, so current I2 is considered as higher current than current I1. Now this constant current source exists between two meshes, so we cannot solve this problem using simple mesh analysis technique. In order to solve this problem, we have to switch super mesh analysis technique. In this technique, we have to omit current source that exists between two meshes, and this current source can be omitted by open circuiting it from the rest of network. So the circuit diagram will become, we have open circuited here, so current source is omitted from this network. Now only two meshes are left inside this network. One mesh will be formed using this path highlighted in green arrows. So first of all, we will apply Kirchoff's voltage law inside this mesh to find its current equation. We will start from here. Current entering terminal is positive, so voltage across this 2 kilo ohm resistance, that is the product of current I1 and 2 kilo ohm, will be taken with positive sign. Next, current entering terminal is positive, so voltage across this 3 kilo ohm resistance will be taken with positive sign, that is the product of I1 and 3 kilo ohm. Similarly, current through this 4 kilo ohm resistance is I2. So voltage across this 4 kilo ohm resistance will be the product of I2 and 4 kilo ohm, and because the current entering terminal is positive, that's why voltage across this resistance is taken with positive sign. Next, current entering terminal is negative, so 12 volt will be taken with negative sign. Next, current entering terminal is positive, so voltage across this 6 kilo ohm resistance will be taken with positive sign. Now two currents are passing through this 6 kilo ohm resistance. One is I3 and other one is I2 because this resistance is in common with two meshes. So current through this 6 kilo ohm resistance will be equal to the difference of these two currents. Now we are considering voltage across this 6 kilo ohm resistance according to the direction of current I2. So we will consider current I2 is larger than I3 and the difference of these two currents will be equal to I2 minus I3, and that difference will be multiplied with 6 kilo ohm in order to calculate voltage across this resistance. So voltage across this 6 kilo ohm resistance will be equal to I2 minus I3 multiplied by 6 kilo ohm. Similarly, two currents are passing through this 3 kilo ohm resistance I1 and I3 and both are opposite in direction to each other. So their difference will be equal to I1 minus I3. Here I1 is considered higher current than I3 because voltage polarity across 3 kilo ohm resistance is taken according to the direction of current I1. So voltage across 3 kilo ohm resistance will be equal to I1 minus I3 multiplied by 3 kilo ohm. And because current entering terminal is positive, that's why voltage across this resistance is taken with positive sign. Next, current entering terminal is positive, so 8 volt will be taken with positive sign, and at the end current entering terminal is negative, so 10 volt will be taken with negative sign. Now solve this equation, open these brackets, take the products of variables inside brackets with values of resistances. The equation will become 2 kilo I1 plus 3 kilo I1 plus 4k I2 minus 12 plus 6k I2 minus 6k I3 plus 3k I1 minus 3k I3 plus 8 minus 10. Now add all same variables together. 2k I1 plus 3k I1 plus 3k I1 will become 8k I1. Similarly, 4k I2 plus 6k I2 will become 10k I2. Minus 6k I3 and minus 3k I3 will become minus 9k I3, and here minus 10 minus 12 will become minus 22 and plus 8 will become minus 14. Now place this constant on the other hand side of equal. The equation will become 8k I1 plus 10k I2 minus 9k I3 equal to 14. Now we cannot further solve this equation, so label this equation as equation B and move to next mesh. Now second mesh will be formed inside this closed path. Write KVL equation for this mesh. Start from here. Current entering terminal is positive, so voltage across this 3 kilo ohm resistance will be taken with positive sign. Now this resistance have two currents from it. One is I1 and other one is I3. Both are opposite in direction to each other. Voltage across this resistance is taken according to the direction of current I3. So current I3 will be considered higher than current I1. So current through this resistance will be equal to the difference of these two currents I3 minus I1 multiplied by 3 kilo ohm will be equal to voltage across this resistance. Similarly, voltage across this 6 kilo ohm resistance is taken according to the direction of current I3, and this resistance have two currents passing through it. One is I2 and other one is I3. Now voltage across it is taken according to the direction of current I3. That's why current through it will be equal to I3 minus I2 multiplied by 6 kilo ohm. Similarly, voltage across this 6 kilo ohm resistance will be equal to the product of current through it and the value of resistance. Current through this 6 kilo ohm resistance is I3 and the value of resistance is 6 kilo ohm, and current entering terminal is positive, so voltage across this resistance will be taken with positive sign, and the value of voltage will be equal to the product of I3 and 6 kilo ohm. At the end current entering terminal is negative, so 8 volt will be taken with negative sign. Now open these brackets and solve this equation. The equation will become 3k I3 minus 3k I1 plus 6k I3 minus 6k I2 plus 6k I3 equal to 8. This minus 8 is placed on the other hand side of equal. Now add same variables together. The equation will become minus 3k I3 minus 6k I2 plus 15k I3 equal to 8. and this equation will be labeled as equation C because it cannot further solved for now. Up to this point we have three equations. The first one equation was I2 minus I1 equal to 2 milliampere. Second equation is 8k I1 plus 10k I2 minus 9k I3 equal to 14. And third equation is minus 3k I1 minus 6k I2 plus 15k I3 equal to 8. Now in order to calculate the value of current I3, we will further solve these three equations. For that purpose, first of all, if we observe, we can find out the value of current I2 from this equation by placing this minus I1 on the other hand side of equal. So I2 will be equal to I1 plus 2 milliampere. Now we can replace the value of current I2 inside these two equations so that we can omit one variable I2 and only two variables will left inside these equations, I1 and I3. For that purpose, first of all, we will place the value of I2 inside this equation B. I2 is replaced with I1 plus 2 milliampere. Now open these brackets. Product of 10k and I1 will become 10k I1, and here product of 10k and 2 milliampere will become 20. Now add 10k I1 and 8k I1 together, it will become 18k I1, and place this plus 20 on the other hand side of equal. The equation will become 18k I1 minus 9k I3 equal to minus 6. This plus 20 is converted into minus 20, and plus 14 and minus 20 will result minus 6. Now we will label this equation as equation D and replace current I2 inside equation C with this equation. Here current I2 is replaced with I1 plus 2 milliampere. Open these brackets, take the product of minus 6k and I1, it will become minus 6k I1. Similarly, minus 6k and 2 milliampere will result minus 12 volt. Now place this minus 12 volt on the other hand side of equal and add these values together because both of these have same variable. So the equation will become minus 9k I1 plus 15k I3 equal to 20. And this equation will be labeled as equation E. Now we have two equations, equation D and equation E, which have two variables only. And from these two variables, we are interested to calculate the value of current I3. So we will try to omit variable I1 so that we can calculate the value of current I3. For that purpose, we will multiply this equation E with 2. The equation will become minus 18k I1 plus 30k I3 equal to 40. And add this resulting equation into equation D. Now this minus 18k I1 and plus 18k I1 will cancel out with each other, and the sum of 30k I3 and minus 9k I3 will become 21k I3, and 40 minus 6 will become 34. Now divide on both sides with 21k so that we can calculate the value of current I3. That will become 1.62 milliampere. Now we have the value of current I3, and as we have discussed earlier, if we have the value of current I3, we will be able to calculate voltage V0 across this 6 kilo ohm resistance that are required in scenario to calculate. So voltage across this 6 kilo ohm resistance will be equal to I3 multiplied by 6 kilo ohm. Replace I3 with its value and take the product of 1.62 milliampere and 6 kilo ohm. So voltage across this 6 kilo ohm resistance will become 9.72 volt. So this was chapter 3 learning assessment E3.18. Thank you. See you again in next video.